Next up, we have VP Consulting, and they're going to talk about digital twin as a solution for major operations and business challenges. We have Claudia Vasquez del Mercado, Alejandro Nila, and Jose Garcia presenting.
Thank you, John. So I'll share our presentations. Well, just a little introduction. VP Consulting is a Mexican consulting firm. We study everything on the value network, supply chain, logistics, and we've been applying digital twins specifically for logistics challenges because of the recent pandemic wave that in the face of the e-commerce growth and made these challenges of logistics and responsiveness like the trend topic. So digital twins have been helping us face these kind of challenges. Here is Jesus Garcia, who is the operations director for Estafeta, which is one of the largest parcel companies in Mexico. And well, he was our sponsor and he was a customer of the solution. And we have Alejandro Nila. He is a PhD on operations research, and he's been our guru on programming and making this possible with AnyLogic. He was an early adopter of these technologies in Mexico, so we have learned tons. I am Claudia Vasquez del Mercado. I'm partner at VP Consulting, and my experience has been for 15 years in consulting with this specialized on supply chain and logistics. So I will share our presentation. So there we are. So this is for a parcel distribution network, and like in summary, the challenge was this intricate systemic network of 130 facilities that are connecting parcels every minute. What we achieved is the visibility to act on synchronization strategies that made a significant financial impact. The method, well, we used this digital twin with AnyLogic, and we used features such as built-in database, agent-based modeling, discrete event simulation, and GIS map. So we are going to talk about this. Jesus.
Thank you, Claudia. Hello, everyone. Thanks for the invitation. Well, let me talk a little bit about Estafeta. As Claudia mentioned, we are one of the largest parcel companies in Mexico. We are in the top 3. We move around 6 to 8 million parcels per month. And for sure, we cover all the Mexican territory. We're talking about 2 million square kilometers. It's look that Germany is in Mexico 5 times. So we cover 99% of our zip codes. So we achieve to around 100 million Mexican people in the territory. And for sure, it's very complex to cover that because our roads are not as good as in the rest of the other countries in Europe or US. So we do that with 450 vehicles, truck deliveries for long hauls, and around 5,000 vehicles for last mile deliveries. We have 6 aircrafts, and for sure the complexity to do this distribution, we need a help of technology. And BP was a great partner to do that, and we make big achievements with the tool that Alejandro is going to talk. And I'm so glad to share with us the great results that we have to do that.
Thank you, Jesus. Well, in collaboration with us and enabled with this digital twin built on AnyLogic, Estafeta was able to better synchronize collecting, sorting, connecting, and delivering operations. We identify and overcome capacity constraints across the network, resulting in 21% of throughput increase. We were studying how to best use the capex budgeted to face this growth from e-commerce. So we were trying to understand where this capex was needed. And what we found with this digital twin is pure synchronization. We didn't have to invest a penny to find 21% throughput increase. So this was a huge breakthrough because this made the growth with unprecedented profitability. So we postponed $25 million for 2 years, and it was kind of obvious that they needed to invest capital to face this kind of growth. But in the end, it wasn't the correct answer. The assertive answer was just to synchronize. And we have never been faced with this kind of optimization. And it was just because a digital twin gives you the kind of visibility that any other study can't. And this was a huge learning, and we've been like shifting our paradigms of how to increase capacity, and synchronization with digital twins has been a great efficiency that we are implementing with other customers.
Thank you, Claudia. Thank you, Jesus. First of all, I'm going to talk to you about simulation. I'm going to talk to you about supply chain, and then I'm going to enter to the features that we used on AnyLogic. I'm going to show you to talk to you about, first of all, I'm talking about simulation and supply chain. First of all, when we use the supply chain design, or when we design a supply chain, we always use an analytical form and an statistical models. These statistical models don't help us to see the dynamics of the networks. So then here in a digital twin, we managed to solve this problem and to analyze the dynamics of every time. So talking about the features of AnyLogic, the first thing, and talking about the first thing about a digital twin, we use the built-in database capabilities to connect digital twin to the real world. So we took historical and, of course, forecasted demand, not forecasted demand for the month or for the week, but minute by minute, parcel by parcel, to see the behavior of the customers, and also to input the transportation number of assets, number of hubs, and also using APIs, the schedules. These network paths were inside the database to know from where to where the parcels must be and must go at every time. So I can tell you, this simulation and these advantages take you to another level. The thing is, you can see supply chain as an static way, or you can see supply chain in a dynamic way. This dynamic way to see it can help you to see what's happening every minute and in every place. So this built-in database and this connection to the real world by database connection help us to not only to see the supply chain as an static way and in a dynamic way. Then, talking about the other features that have AnyLogic that help us, we can also talk about discrete event simulation. This discrete event simulation is the classical simulation of every hub, and in every hub, the process of sorting, the process of delivering, and in the process of sorting and process of delivering, also taking resources, and these resources that make everything happening. So this is discrete event simulation working in a classical way. We managed to put them in a GIS map. This GIS map enables the observation and the transportation dynamics. So in the map, you're going to see the video in the same way, and then every place and everything is modeled also agent based. So what's happening in agent-based modeling? You can scale the model. You can do only one model for discrete event for every hub and for every asset, and then you can reply it 100 times or even 1,000 times if you like. Then you can also have the option to simulate the transportation behavior and the scheduling. You can also simulate the business interaction that you can take from experts and from everyone of the company. And then it allows to have you the same indicators, not only on main agent, but in every hub and in every agent and in every asset. And then last of all, on on this map, I'm going to show you the video. If you can help me, Cloud, please. This this model was provides the detail and is enough detail to analyze these complex systems and the logistics change. You can see in the picture every truck, every plane, and also the exact time when every plane gets to land or to departure. Then and on every second and on every place, the agent-based model helped us to have the schedules to interact with also planes with hubs, hubs with planes, and also with trucks at every time at any moment. Then we're going to enter into a truck. The trucks don't have not only have schedules, not only need to interact with hubs, but they have their own capacities, and these own capacities and their own take the services from a place to another in different ways, in different times to get a parcel from a zip code to another zip code, even in a place from Mexico in the south and to the north place. You can see already now in the picture how the demand works and how the demand behavior is made of Estafeta. We can see not only the total demand, but every customer demand and the behavior of every customer at any time. So we can take decisions about that, not only about customers, but also about products and about services. On every discrete event simulation, on every hub, we can catch peaks, we can catch valleys, we can catch operations, and we can see if resources have enough at the same time, at a certain moment, with, with wherever we need. So we are seeing the main hub, and you can see these big peaks on every hour. And then if I go to another to another place, to another hub, you can see where you can sort, where you can deliver, and how the demand is not the same. It's not the same where you are collecting, and not the same where you are sorting all the demand. So these decisions of the time, these decisions of the customers, and these decisions of the service or the product, that's what made us to solve anything that we needed at a certain time and get to the business solutions that we needed. So last of all, you are seeing the again the model, and then this visibility and these efficiencies are the consequences of an accepted plan and spend of capital investment. Thank you, Clau. Thank you, Jesus.
Yeah, so complementing what we found with the digital twin in the actual operation is that two processes were overlapping, but we didn't understand how they overlap, like along some windows of time, how this overlapping was affecting the rest of the system. So it was almost it popped out, like in the graphs that are shown here. Like just by looking at the graph, we were able to see this kind of obvious situation, but it wasn't obvious at the moment within the operation. So looking just at the graphs, because the analysis is in this minute per minute, we were able to catch this hour in which the overlapping was happening, and that how was affecting the rest of the operations for more than 1 hour. So this was one of the breakthroughs for the 21% throughput increase, and we just had to sequence. We didn't have to invest any pennies. We just have to sequence that process in that moment in that specific location, and then we found this capacity immediately. The other thing that was very useful was to measure. Maybe you can see here the backlog, the duration of the backlog. So when we are operating, we feel the backlog because we see the parcels like piling up, but we don't know how much time the backlog is going to last. So when the boom of e-commerce came, the backlogs were lasting for days and days and days, and we didn't understand like the paradigm that was shifting and how long was that going to prevail in our lives. So with this analysis of backlog duration, it was very easy to understand that some backlogs are part of life and some backlogs need attention. And that also made more assertive the way we were investing and spending, because some backlogs were like, we are just going to live with this, but now we know it's not a surprise. So that was also a huge breakthrough in this case. So I don't know if there are any questions, but we were very, we tried to be very concise. What variable was the model most sensitive to in improving outcomes? Like, I don't know if the rest of people see the questions, but the question is, what variable was the model most sensitive to improving outcomes? I think it was synchronization, like the way we could see everything happening minute by minute, hour by hour, but in the interaction of each facility with each facility, that was the variable that is not visible when you are like studying an static logistics behavior. And looking at it dynamically, we were able to find these synchronization opportunities.
And also with which clients we can make postponements, because not all of the clients contract the same time deliveries for different cities. So with this synchronization, we could be able to know which clients could stay in some specific city, maybe in the main hubs, in order to achieve more productivity in the transportation, and which others we could move faster than the speed that we have at this moment. With this visibility, we can take decisions much more easy in each facility. It helps us a lot in order to improve the service levels agreement that we have with our clients.
Yeah. There's a question, what does the built-in database in AnyLogic mean? How do we access? Can you answer, Alex?
Well, thank you. Well, in every model, you have a database that it's built in the model in AnyLogic. So you can access by, I don't know, you can access only by creating the model. You have the database built in on it. And you can access from code, you can access from every block, and you can access from every agent on the model. Thank you, Clau.
Mm-hmm. How do you develop the conceptual model? Well, that's a very good question. Well, we have in BP we have a mindset of network modeling. So I think that was the first paradigm. We started like thinking about a network, and then Jesus has has a detailed understanding of his own network. So he understood that this synchrony, that the systemic behavior, like one side affecting the other, was the main variable affecting his system. So then that's where we focused on this systemic behavior in which all assets needed to be connected, because what happens in one asset affects the other one and then the rest. And I think it was like in summary, like this expert judgment of logistics and parcel movement. But we didn't know. We were like building it by the moment. Like this, for example, this backlog time frame was Alexa's idea, I think, with one of the operations leaders, that they understood, like, okay, this happens, but what's the time frame of this happening? And then they introduced that into the model. I think it was like just finding what may be affecting, like sensing what may be affecting, and then testing it in the digital twin. It says, does the data represent the real-time data? It's not connecting to the actual operation happening, but it's the real events history. So what we are doing is using this event history, like by the minute, and then we replicate the behavior, but for forecasting forecasted volume. So it's a real behavior, but it's not connected in real time. I don't know if that answers the question.
But we can use predictive forecast in order to put in this simulation, in order to know what's going to happen with some quantity that we expect special for the peak seasons. So we can run according with the scheduling that we have in the vehicles, with a very specific quantity for each region, and it helps us in order to know if we have to add more vehicles or we have to add aircrafts, of which model is better, if we put the deliveries in aircrafts or in trucks. So it helps us a lot to make these kind of simulations.
Mm-hmm. How long did you take to build the simulation model? If I recall correctly, it was like 4 months to build the model, and then it took us like 6 weeks to analyze the outputs. But in average, I think these kind of models are taking us 2 months approximately. Did you use optimization in achieving the model's goals, Alex?
No, we don't. We're also specialists on AnyLogic and in optimization. So optimization is a pre-work. Optimization not only about an analytical optimization, but an empirical optimization with the customer. So in this model, optimization is not that important. It's more important the expertise of the customer and the expertise of the consultants.
Mm-hmm. Yes, we have been using optimization, and sometimes the temptation of solving all problems with optimization is there, but we are understanding that not everything is solved with optimization, and then we're finding these new paradigms of solving these kind of problems. But for sure, it's very useful, and we are exploring now, because we are not experts on it, but on using optimization within AnyLogic. It says, how do you consolidate all these graphs into a snapshot overview of the network? Or are you actually drilling into the model to see what is happening?
No, I consolidate all the graphs on. I have a button, a simple button that takes everything to an Excel spreadsheet if you like, and then you can consolidate all these graphs, and you can make your pivot tables and everything that we all like.
Yeah, so the graphs are visible during the simulation, and they gave us some insight during the simulation. But to analyze them like afterwards, we use the actual output, the actual data, and then make the graphs for our conclusions. It says, is your digital twin still operational, or once you fix the bottlenecks, did you decommission it? I mean, did you set out to build a digital twin, or did you want to solve a specific problem?
Well,
That has many answers.
yeah, for sure. At the beginning, the digital model helped us a lot to find out the bottlenecks and solve it. And now we use it for specific seasons. For example, right now is coming our peak season in November. So we are using that in order to model which could be the best distribution model that we can use it. And for some big clients that arrives, we use it in order to simulate which is the best way to achieve the goals or fulfill the service levels agreements that we have with these clients. So it's operational and we use it a lot, definitely.
Yeah, it's for tactical decisions. It's a challenge to have the teams adopt it, because it's a very different mindset to plan operations. Specifically to logistics mindset, it's a little bit tough. But yeah, once, like, I think the results are very easily adopted because they are breakthroughs, but the process of using it takes a little bit more time. And then we as consultants need to understand that we have to be there to make it easy for the actual logistics teams to adopt the process of planning with a digital twin, because the results are very easy to adopt, but the process of planning with it's more difficult.
Yeah, and it's something that is so important to clarify, because the tool helps us a lot to optimize our net distribution, and it give us a lot of productivity. But sometimes we need to combine with the service levels agreements, to be honest. Sometimes it's important make a little twist in the optimization in order to achieve some goals. So it's so important the experience of the people who is operating the tool in order to combine commercial objectives and productivity objectives. And then this is supply chain. How can you manage this? And it helps us a lot and save a lot of hours putting this in the digital model instead a lot of people trying to estimate in Excel files, to be honest. This is something that we learn using this tool.
Okay. Well, I don't see in our chat any more questions. So this is it. Okay, so thank you very much. It was a pleasure to be here, and looking forward to listen to other companies. Thank you.
Awesome. Yeah, thank you, everyone. Thank you for sharing how we can use digital twin to help with business problems.